Okay, so we want to show that this guy is decreasing, kind of weird to look at. So I do a sub n plus 1 is less than a sub n. If I plug in n sub 1 here, I get n plus 1. E to the negative n plus 1 squared is less than n to the negative n squared. I don't really know any sort of tricks that I can do to build this series here like I did on the other ones. So if it's kind of a complicated looking function, the only way you can show it's decreasing is by doing some first derivative. So I'm going to rewrite this as f of x is x to the negative x squared. I take the derivative, I get e to the negative x squared, using the product rule here, minus 2x squared e to the negative x squared. So I'm going to set this equal to 0. Negative x squared minus 2x squared e to the next squared is equal to 0. I'm going to take out a negative x squared and I get 1 minus 2x squared is equal to 0. This thing's never equal to 0. It's always positive, so I'm not really too interested in that. This thing over here, if I set it equal to 0, I get x squared equals a half, so x equals plus or minus the square root of a half, which is a pretty small number. Note that I'm looking for 1 to infinity, right? So I don't really, this 1 over, so this is 0, 1 over radical 2 is pretty small. It's going to be less than 1, right? So I don't really care about that. I just want to look at some value from 1. I just want to look at some number way out over here. So 1 over the square root of 2 is here, because 1/2 is here. If I square root of that, it's going to be even smaller. So here's 1, which is to the right of 1 over the square root of 1 over radical 2. I don't care about the negative square root of a half, because again, I'm going from 1 to infinity. So I'm just going to do f prime of 1. I'm just going to plug it back in this thing here. I get, this is negative e to the negative 1 minus 2e to the negative 1, right? Because there's a 1 squared in here, 1 squared because of this guy right here. This just becomes negative e to the negative 1, which is less than 0. So therefore my series is decreasing on 1 to infinity. Okay? So again, if it's kind of a weird looking function, it just doesn't have n's in it, you have to do the derivative test. You have to figure out when the derivative is equal to 0, and then just do a test value that's to the right of usually 0, and then say that the series is decreasing.